QSO Today, Episode 411, Eric Anderson, AF7YQ. My thanks to ICOM America for sponsoring the QSO Today podcast. The QSO Today Virtual Ham Expo is coming September 17th and 18th, 2022. If you have a ham radio story, technology breakthrough, or project that you'd like to share at the expo, please sign up by going to this week's show notes page and clicking on the image. We also have some amazing enhancements to our Kumo Space lounges this time around and are anxious to share them with you. Stay tuned. There are a number of ways to support our QSO Today podcast and projects, including just clicking on the sponsor's menu item or using our affiliate links to get to products and services listed. These vendors give us a little spiff for our sending them your business to make this a win-win solution for all of us. Welcome to the QSO Today podcast. I'm Eric Guth, amateur call sign 4Z1UG, where I demonstrate the diversity and relevance of the amateur radio hobby and its impact on society by interviewing ham radio operators, many of whom played vital roles in shaping our technology through the amateur radio hobby. And while many people might say, ham radio, do people still do that? This podcast demonstrates through in-depth interviews just how amazing, diverse, and dynamic the amateur radio hobby continues to be. Eric Anderson, AF7YQ's ham radio interest, led him to advanced degrees from MIT and to become the chief architect and camera software manager at Apple's Advanced Technology Group, creators of the first LCD-based cameras, chief technology officer at FlashPoint, and owner of more than 140 patents. Now retired, Eric creates unique ham radio CW transceivers for his new company, Preppcomm. AF7YQ is my QSO Today. AF7YQ, this is Eric, 4Z1UG. Are you there, Eric?
I'm here. This is AF7YQ responding.
Eric, thanks for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
I was in high school. My dad had been a ham before the war. He decided to get his ham license again, got an extra class, and we went out and found, or he went out and found a AM, 1 kilowatt AM station that was hand built in somebody's, leftovers being sold off for, cheap. So it was a 6-foot high rack, believe it or not, and great big huge tubes, single tube in the final, and two big tubes in the push-pull modulator. When he made this first contact, I was so excited. I jumped up and banged my head on the ceiling in the basement. So of course I was watching this all, and got very excited and interested. I had as a hobby at that point. I had electronics as a hobby. So I decided to get my license, and of course, in those days, you had to do the code.
Let's go back a little bit before we go there.
Yeah.
What was the hometown?
This was in Rochester, New York, of all places.
So Rochester was home of Kodak, right?
Yes. So we called Kodak the giant yellow mother.
I've interviewed a number of hams from Rochester, New York. There were a lot of hams in Rochester, New York during those days, right? And this is what, are we talking the 50s here?
That would be in the 50s. In fact, there probably were a lot of other hams. My dad was not really connected into a ham club or anything like that. So from my experience, it was just me and talking to people over the air. There was no ham club, although I'm sure there was plenty of those.
How did you become interested in electronics? And what age did you start having an interest in electricity and electronics?
Well, that's a good question. I know I got involved in doing science fairs. I think the first one I did was electromagnetism, and I built a doorbell and a few other iron filings, on a piece of paper with a magnet underneath and stuff like that. And then I went through I had another one with an aquarium. That was a disaster. And then I got into electronics again, and in my senior year, I actually built a AM radio station. When I say AM, I mean AM as in broadcast. It was carrier current, and for those of you who've been to a campus, typically there's a campus station that's carrier current, and it's that you actually transmit the radio frequencies into the power lines. So I built one of those, and when I got home from school, I went on the air, as it were. We had a 2-hour radio program. One of them was called the Eric Anderson Show, and the other one was the Top 10.
You were broadcasting into the AC lines in your neighborhood?
Yeah, and we had about a 3-mile radius. So,
just out of curiosity, what was the legality of using carrier current?
Well, carrier current is legal. The level of power is regulated at a certain number of microvolts per meter at a certain distance from the power line. But who has an expensive meter like that as a kid? So, we didn't have any clue whether we were above or below the limit, and we didn't think anybody would ever notice. So, and in fact, nobody did. So we actually had broadcast out of stores for a week, and we charged 60 cents a minute for advertising. I mean, it was quite an interesting experience.
And did you end up having a pretty good listenership? And how did you know if you had a good listenership?
Well, that's a good question. Who knows? But we did have a top 10 thing, and we had a voting box down at the center of town. And we had our own top 10. We actually got, when the record companies were issuing 45 RPMs to the radio stations, and the radio stations would pick out the ones they thought were going to be winners or however they did that. And then they had a stack. I mean, I'm talking a big stack of 45s that they didn't want. And we had a friend at the radio station, and we got those. And we would go through them and pick out what we thought were the good ones and play them. And we actually had a couple of winners that we had all mathematical formulas, for how to maintain the numbers and how people voted, and then it would have a fade-out period if nobody voted for it and that kind of stuff. But, yeah, we had our own top 10, and we had this one hit that what people just loved, and we got quite a few votes. So
you really did have an audience. In carrier current, the way that it works is you're actually transmitting in the broadcast band, or at least in the pass band of the AM receiver that most people had, right?
Correct. Yeah, we were at 170, 1.07 megahertz.
Does that mean you're a pirate station, or because it's carrier current, you're not a pirate station?
No, I mean, it's legal, assuming that we were within the limits that the FCC stipulates. We just didn't have the test equipment to find out if we were.
Well, I think that's pretty cool, actually. I've spoken to people that have done carrier current on college campuses, to dormitories and stuff, but I've never actually spoken to someone that actually did it in their town and had non-students listening to the AM broadcast. So does that mean that when you left high school that you had an interest in being a broadcaster?
I went to the University of Rochester for my undergraduate, and they had, of course, a campus station, and I got involved in that. Not from the broadcast side. I mean, I did have my shows on at home, when we were broadcasting from home. I was not interested in that side in terms of professional. I was interested in the electronics side, and so I was in electrical engineering at the University of Rochester.
And when did you get your amateur radio license? Do you recall? Were you still in high school?
Probably. The best I could do was 13 words a minute. I was sweating bullets. I think the testers cheated. That is to say, I don't think I really passed. It was so bad when I was trying to decode. I was sweating bullets, and I was missing all kinds of stuff. But they still passed me.
Was the general class your first license, or did you go through the novice?
Yeah, that'd be general. 13 words a minute, general.
Your first license was a general class license, not a novice license. You didn't do the 5 words a minute.
Right.
Okay.
Yeah, I wanted the access to. The technical stuff was easy for me naturally. It was the only thing limiting me from getting an extra class, which is what I really wanted at that time, was the code. I just couldn't do 20 words a minute. I would barely do 13.
Do you remember your first call sign?
WA1PMF, William Abel 1, poor man's friend. No, I'm sorry. That was my second call. My first call was WB2USQ. And then when I moved to MIT for graduate school, I was required by the FCC to change my call sign. Back in those days, you couldn't keep your call sign.
If you moved from area to area, what year was that you got your first license?
It was in the late 50s.
So you have this interest in electronics. You go to University of Rochester and get a BSCE. And then you say that you went on for an advanced degree?
Yeah, I went to MIT. I went into the computer science curriculum, got involved in artificial intelligence. It was interesting. I basically got to did all the coursework for a PhD and decided I didn't want to get a PhD. And the reason for that, there was a couple of reasons for that. Two reasons. One was that they said, well, for the next 4 years, you have to make engineering the most important thing in your life, and I wasn't interested in doing that. And number two, I wasn't interested in research. I wanted to do product development. I loved tinkering. I loved designing. I loved building products. So I ended up getting what they call an EE degree, which is in computer science, which is a PhD without a thesis, basically. So that was kind of my parachute out of the PhD program at MIT.
Eric, we have this idea, at least, now it's 2022, what artificial intelligence looks like. What did artificial intelligence look like in the early 60s in terms of how was it approached and how is it different from today?
Well, it was very, very primitive, of course. And really, I think that's a misnomer. Artificial intelligence is a misnomer because it's the programmer's intelligence that you're experiencing, not the machine's intelligence. So it's really a transfer of human intelligence to the machine by codifying how smart the programmers are into code. One of the things we had on campus was a program called LISA, and it was running on the time sharing system. In those days, we were using teletype machines for talking to the computer or selector typewriters, and we would take our girlfriends over to the computing center and run LISA and have them. We would type in what they wanted to ask the computer, and then of course the computer would respond. And it was supposed to be a demonstration of somebody's rule that if you could make the machine sound exactly like a human, then it was a human, right? That kind of thing. I forgot who that was that said that. And we had a lot of girls convinced that there was a person at the other end of the wire, and we were just kidding them. And that was a very simple program. I mean, it basically looked for keywords in your sentence. There was no, of course, speech recognition. It was all text because you're typing it on the keyboard. And it would look for things like mother, father, sex, things like that. And then it would start asking you psychological questions like, did you hate your mother? That kind of stuff. And it was very cool and fun until the day that they discovered, the system administrator discovered that all the users on the system, this is a very expensive IBM time sharing system, every single user was running in LISA, so they shut it down. It came back later, but it was pretty funny. But that was the state of artificial intelligence, and the goal was at that point the belief was kind of like Asimov kind of approach, that if you could get the machine to learn by itself, the so-called machine learning, it could learn and learn and learn, and after a while it would learn enough that it would actually get smarter than you, and then it would take off and become super intelligent. The problem with that theory is, and that's, by the way, what they believed back then. They believed that within 20 years, we would have a machine that was smarter than humans. That would have been, let me see, that would have been...
like 1980.
Yeah, 1880, right, exactly. Of course, that didn't happen, and the reason it didn't happen is just based on a faulty assumption, and that is that it happened in nature, and therefore it could happen in a computer. And it didn't happen in nature, I don't believe. See, that's the difference. It's a worldview, whatever your worldview is. I believe we were created, not evolved. So if you believe we were evolved, then yes, you will believe that a computer can evolve in the software if you can figure out the mechanism for doing that. Natural selection, blah, blah, blah. But, the reality is that nobody has been able to do that. And people have tried. There's a program called Life that runs you may have seen it. It runs on a computer and tries to simulate life, blobs of things moving around the screen. I mean, the reality is, more we learn about life, the complexity of the human cell, or just the cell, and the machinery, the nanotechnology in there that makes the cell work, It's literally molecular nanotechnology, and there's no way it could have just happened by accident.
So if we're talking about artificial intelligence, then in order to even replicate the neural pathways of the human brain, we may be approaching having supercomputers now and processing speeds and memory and stuff that will kind of get close, but this has been an evolution from a technology standpoint since the 60s.
Yeah.
And we're still not there.
Well, it's not a matter of neural pathways or how much memory you have. I mean, or how fast your computer is. It's not. That's the problem. I mean, it's what program are you running? What program are you executing in that array of pathways? How do you invent one that actually is alive? What is life,
So there's a lot of open questions that revolve around whether we've created a computer that is really like us.
Well, here's a science fiction thing for you. I can't remember which writer had come up with this, but the basic idea, maybe this is actually scientific instead of science fiction, I can't remember. But something of order n cannot create something of order n squared or n plus 1. In other words, if we're at a certain level of intelligence or complexity, we cannot create something that is greater than us. We can create things that are lesser than us, but we can't create something greater than us. There's somebody that's postulated that as a rule. I don't know if it's true or not. It's an interesting theory. I suspect it's true, however.
What happened after MIT? So you got your EE in computer science from MIT. Where did you go after that?
Well, let's talk about ham radio at MIT.
Okay, let's do that.
Yeah, because, those are the glory days, man. I got myself a Hallicrafters SR2000, 2,000 watts PEP. It was a marvelous machine. Oh, my gosh. The power supply weighed a couple of tons. And I had that in my room at the MIT.
What was the receiver?
It was a transceiver.
Oh, it was a transceiver.
Yeah, transceiver.
This is the first time I've actually heard of the Hallicrafters SR2000.
It was a beauty. It was so stable. I mean, I had a Atlas or something before that. No, it wasn't Atlas. It was, I can't remember the name of the company, but it drifted so fast. I literally had to turn the dial slowly, listening to somebody else, and then they had to turn the dial slowly to follow me when I'm talking. It was that bad.
You had this Hallicrafters SR2000 in your room at MIT. How were hams treated at MIT in those days?
They didn't really know about it. I mean, so I had a cable running up the side of the building to a dipole. I had a 80, 40, 20, 15, and 10 meter dipole. If you were driving across the bridge, the Harvard Bridge, and looked up at the top of the building, you would see a 2x4 sticking up, which was what was holding up one end of the antenna, and the other end, of course, is the other end of the building. And but nobody really paid any attention to it. And when we hit the transmit button, every single radio, record player, whatever, in the entire building went on the fritz. And believe me, if they knew where that was coming from, they would have killed me. But they didn't.
No, but when you think of MIT, you think of that every student must have some kind of diabolical technology they're operating in their room or something like that. Is that the wrong perception?
Yeah, it's pretty wrong. No, actually, it's amazing. I was surprised by MIT. I was disappointed by MIT, actually. It looks good on my resume, and it was very helpful for getting a job at Apple. But I didn't actually learn anything at MIT, I don't think, that I actually ever used in my life. I mean, I didn't learn electronics. I learned electronics at the University of Rochester. The University of Rochester was an incredible experience. It was very powerful learning environment, small classes, great interaction with professors. We started off with a class of 50 and end up with a class of 15. We did down because they turned out, they threw the dart at the board of possible, things they could take, and they hit electrical engineering, and then they discovered, geez, I don't like electrical engineering. So, but I was really into it. I loved it. So when I would learn something in an electronics course, I would go home during the weekend and I would build it. And the first time I got a transistor to work was after I learned how transistors worked. I mean, I was using tubes up to that point. I never could get a transistor to work. So I was really into it. So at MIT, it was all intellectual. There was very little practical. Now, certainly there were professors doing things like we had robotic arms, doing stuff in AI and stuff like that. But it was more theoretical, and there was the problem was most of the people there were, you could argue from an intellectual point of view, the best of the best, but that actually causes some very serious, what would you call, social issues.
I can only imagine.
The undergraduates, it was the worst. I mean, they had been the best in high school. They had always won everything, and they got there, and suddenly they weren't the best of the best anymore. It was devastating. People would commit suicide. We had a regular suicide rate. I mean, it was, never heard of that at the University of Rochester. So, it has a great name because it does a lot of research and stuff. But frankly, and from a point of view of what I learned there, I was not impressed.
Were you unusual, do you think, being someone who would actually take a lab experiment home and build it yourself?
Absolutely. There was nobody else in my class that did that.
Did that surprise you at the time?
I'm not sure it surprised me. I mean, that was the way it was. They would memorize formulas. They didn't know what they meant, but they would memorize them. So I had a friend who he would have a stack of books and studying for an exam. He would have a stack of books, and he would know if he had a question that he was supposed to answer. He would know which book to look in to find a question like that. That's how he operated. And unfortunately, that guy's a doctor today. I wouldn't want him as my doctor. Anyway, but he doesn't understand it. I mean, he didn't understand it. And when we did the final exam for electronics, you had to understand the stuff because he had circuits in there that you had never seen before any place. But if you understood the concepts that he had taught in the class, they were easy. I mean, they were simple, but they were not simple from the point of view of this is standard. This is standard. It's standard, except it's way out in the fringe. Like he would have a circuit that had a bandwidth of like a half of a hertz, and nobody ever saw a circuit with a 100 microfarad capacitor across the output. So they thought it was grounded. They assumed it was grounded, so it couldn't have any output. So when they asked, what's the gain of this amplifier and what's its frequency response, the answer was 0 gain. And well, no, that wasn't true. It did have a gain at a half a hertz or lower. So, if you didn't understand it, you just had memorized formulas, you were at total loss. But I loved the exam because it was really challenging to say, let's see, how does this one work?
That seems to be, that's an attitude. And where do you think that attitude came from? I mean, I'm just curious, if we go systemically back to the beginning of Eric Anderson, where does an attitude like this come from in terms of wanting to understand how things work?
Well, I'm a unique person. Obviously, we're all unique, right? We have a unique brains, and God gives us unique gifts. But one of the factors that may have enhanced that is my parents are always because of my legal blindness. Many people who have my kind of condition would kind of withdraw into themselves, and they would essentially end up as wards of the state. Many people in my condition are wards of the state. And that's what a sad story that is, because their life is horrible. I mean, they're just sitting around in a dark room almost and watch. I don't know what they do. Don't watch TV, of course, so I'm not sure what they do. Actually, our ham radio system that we're selling now is one of the things that we're hoping to change some of that. But they would always tell me, you can do whatever you want. You can do whatever you put in your mind. You can accomplish whatever you decide you want to do. And they would tell me that over and over again. I must have heard that a million times. And I'm sure that put into me a determination, to accomplish or to do what I wanted to do and that not be stopped by any mere problem. So that may be a factor. I suspect it is, but I think it's also true that and my eyesight limitation may play a part in that too, because they say that when one of your abilities is hindered, that other abilities are increased. I don't know how that works, but who knows?
To compensate for the environment around you. So what happened after MIT? Professionally, where did you go after that?
I got involved in the startup. I was the chief engineer I guess that was my title at the time. I invented about 55 products and shipped them all over the country. That was in what was called the multi-image industry, which was back in the days of slide projectors, banks of slide projectors, because we didn't have decent video. We didn't have video really at all. I mean, there was video projectors that they had back in those days were really, really expensive, and they were really crappy quality. And we had, essentially HD, 4K HD with a slide projector, right? So we developed techniques where we actually could do video with slide projectors. That was always blew people's minds.
And now this message from ICOM America. Heard it, worked it, logged it. This summer, keep your competitive contesting edge with ICOM. Our high-powered base stations cut through pile-ups, letting you work the bands and log those contacts. Contest from the comfort of your home or remotely with the RSBA1 app. The ICOM IC7851 gives you a new window into the RF world, and its on-air excellence is unparalleled. With faster processors, high input gain, high display resolution, and a cleaner signal, it's truly the pinnacle of HF perfection. Features include dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution Spectrum waterfall display, enhanced PC connectivity, and an SD memory card slot. The ICOM IC7610 is the SDR every ham wants. This high-performance SDR can pick out faint signals in the presence of stronger adjacent signals. The ICOM IC7610 is a direct sampling software-defined radio that has changed the world's definition of an SDR transceiver. Its features include RF direct sampling system, 110 dB RMDR, independent dual receiver, and dual digicell. Create your own band openings with the ICOM IC9700. This transceiver brings direct sampling to the UHF-VHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you busy that include faster processors, higher input gain, higher display resolution, and a cleaner signal. This has become the new de facto standard as a baseband rig for microwave operation as well. Features include 4.3-inch touchscreen color TFT LCD, real-time high-speed spectrum scope and waterfall display, smooth satellite operation with 99 satellite channels, dual watch operation, and full duplex operation in satellite mode. The ICOM IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing inherent noise in different IF stages. The IC7300 changed the way entry-level HF is designed. It is the go-to rig in my station now, and I love it. Features include RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and an SD memory card slot. Just know that you'll be very pleased with one of these fine rigs to enhance your contest, DX, and general ham radio operation in your station. Be sure to check out these ICOM rigs and their full line of base stations and portable radios at an amateur radio dealer near you. And when you make that purchase of a fine ICOM rig, be sure to tell your dealer that you heard about it here on the QSO Today podcast. And now back to our QSO Today. I remember this in the 70s where you'd take multiple carousel projectors on one screen and you'd have dissolve units between each of the...
Yep. We designed and built the dissolve units, and we also did a computer system that had multiple timelines so you could actually run independent sequences without having to manually merge the timelines together, which is what everybody else was doing. So like if you wanted a marquee effect around the screen and you wanted to do a synchronized sequence in the center of the screen to, say, the music, you had to manually merge those two timelines together. And it was very, very time-consuming and painful to do that. With us, you would just go in and you would program the marquee, and then you go in and you click the return button to program each cue with whatever you wanted to program it to, and now you had two timelines running, and the computer would merge them in real time, and we could have up to 4 timelines. and we could run, we had 100 cues per second that we could run, and everybody else is running 10 or 20. So we could do things like actual video where we had a woman speaking on the screen. The first time I saw it, I practically fell off my chair. I mean, I know that, it's one thing to invent the equipment. It's another thing to see it used really effectively. And we had a guy who was a producer in Hollywood, and he did one of our shows called Starlight Fantasy, and it had this woman speaking in part of the show, and the music was incredible. We had some bands and stuff, and it was an incredible show. And it was the first time ever anybody saw a woman lift up her head and open her mouth and start speaking and lip sync with slide projector. And they kept looking for the movie projector. They couldn't find it. It was pretty funny.
That was really amazing stuff. I was kind of involved in some of that where you'd have 6 slide projectors running and sync together. I think we might have been controlling them using an audio tape channel, on a multi-track.
Yeah.
What was the name of the company?
It was called Clearlight. And we had called the Superstar, the Star 3 system, the Diamond system, Micro Diamond system, and we had many different dissolve units and different sizes and programmers. We had the fun part was people, our competitors it was costing them a lot more to stay in business than we had no idea of marketing. Like my current company, we didn't know marketing from a hole in the wall. So our sales were significantly lower than the primary company in the marketplace, which was AVL. But their equipment was very poorly designed. I mean, they had an entire computer board which had, 5 or 10, 15 chips on it when we had just one chip. We had assembly language in a single chip that would do what their computer would do with 5 or 10 chips on a main board with a big power supply. So that was our ability. We took single chip computers, had to burn their ROMs and buy 1,000 of them to get $10 a chip, but that's what we did. We had about 6 different programs on those chips that did the memory programmer, the programmer itself, and the decoder encoder for the tape, and the dissolve control for the 3 projectors and so forth. We had all these different, we had 100 cues a second, or no, it was 50 cues a second off a tape, which was totally unusual, which we had developed the decoder encoder for that, self-correcting. So if you missed a cue, it would automatically resynchronize. So that was the kind of stuff we did all the way up until the early 80s. And then video was coming in, and we weren't interested in video. I just wasn't interested in video. So the company kind of faded out and was sold off to one of our dealers in Boston. And when we shipped them all of our stuff, which had all the files on all the computer chips and all the programs, they managed to lose that somehow. And so when they ran out of chips, they couldn't buy any more because they didn't have the program code. It's like, he calls me up and says, can you send me the program codes for this? And I said, what? I already did. I don't have anything.
So where did you go after that, Eric?
Apple.
Apple was just starting in the 80s.
Well, I didn't get there until 1986, I think it was. Or 1989, I don't know.
But you were early in. I mean, that was really early in at the time.
Well, it's kind of interesting how early it was, because when we were running in Clearlight, we were using the Apple II as our programming system. We had software for that, and we called it the Clearlight Superstar. And we asked Apple for permission to use their logo on our logos. In other words, we would replace the disk drive plates and the logo plate on the Apple II with ours, but it would say Clearlight Superstar, and underneath it would be an Apple logo. And they gave us permission to do that. And then a few years later, when they were about to come out with the Apple IIe, they called us up and said, we want you to stop doing that. And we said, well, we'd be glad to as long as you buy our supply of labels. And they declined. Now, think about that. Think how small the company must have been to decline buying our labels. It blew my mind at the time because I thought, gee, I didn't realize Apple was that small that they wouldn't buy those stupid labels. So, but they came out with the 2E, which the labels didn't fit on. So that's how they fixed that. We still could put them on the disk drives, but we couldn't put it on the computer. So anyway, Apple was interesting. I would say the highlight of my experience in professionally. It was an amazing company to work for. I don't know that it is still, but it was.
How long were you there?
9 years, and actually we got sold or spun out because Apple was not doing well financially in the late 90s, so they had to do something to reduce their expenses. So they spun us out as a separate company, which then unfortunately was doing what Apple should have been doing, but because Apple couldn't afford to do it. And that was the early digital cameras that had, they were basically like iPhones, except they were cameras that had phones, instead of phones that had cameras. So they had a lot of the technology you saw in the early iPhones actually was from patents that I filed in the 90s. I have 150 patents. The most famous one that's easy to see is the image rotation patent. And that is, if you take a picture and then you look at it and then you rotate the camera or the phone, the picture rotates and changes the size to fit. That's actually a patent of mine from 1996. It was filed. It's actually invented in 1994. And that's when we were using a 2-inch screen on a little camera, on a little typical standard SLR camera shape, that kind of a shape. And we were working with a 4:3 ratio screen. But it wasn't a touch screen, but it still ran applications, just like an iPhone does. So we had games and all kinds of junk on it. But yeah, we had a lot of fun doing that. We also shipped a bunch of Macintoshes that had DSP audio and video functions built in. 1995, I think it was, the so-called AV Max that was contained our subsystem was a transition between the 68,000 and the RISC machines. And we also did the Apple II video overlay card, which was was kind of the last gasp in the Apple II division. So that's kind of so I got involved in I was one of the guys who they kept pulling off of projects because when they got them far enough along that they figured they would be successful now without me, they would pull me off that to put me on another project that needed my help. So they pulled me off the DSP project for the Macintoshes when they thought, okay, it's far enough along that the ASIC is working, the computers are working, now it's just the final development stuff. So go in here and save the camera. So they had, at that day, in those days, it was called the Advanced Technologies Group, had actually had a working model of a handheld camera that had full video and still capture, audio capture. It did editing in the camera. It did everything you would actually expect today. Certainly, they didn't expect it then, but you would expect it today. The only problem was there was a cable coming out of it that ran under the table to a Macintosh that had a bunch of video capture cards and stuff like that. And so my job was to take the Macintosh and put it inside the camera. And we did. That's what we did. But it wasn't a Macintosh, of course. But what they meant by that is we want you to take this Macintosh Plus external or handheld device, which is really just some buttons, an LCD screen, and a camera, and a video camera. We want you to put that into one little box so we can sell it as a digital camera. And Apple would have been the first on the market with a LCD-based camera if we hadn't had some stupid managers at Apple who were connected to Kodak and made really bad decisions about where we should get stuff. So we would have been in the market in 1994 or 95 with a digital camera before Casio, which was the first one to come out with a LCD-based camera. We would have beat them, but unfortunately they forced us to switch to Kodak, which was a total disaster.
How did ham radio play in your life during this period of time at Apple?
I was mostly living in places where you couldn't put up an antenna. And so basically ham radio played zero in my life for quite a while there. while I was at Apple. I was, of course, in San Jose, California, in a fairly dense housing community. You couldn't put up antennas there. So basically, after a number of years of that, I just let my license lapse. It wasn't until I moved here into northern Idaho that one of my friends who was a ham said, "Hey, you need to get your license again. Get your license again." So I did, but now because there's no code requirements, I got my extra class, and I used a very interesting method. I used hamtestonline.com.
Right, I did that.
That worked really well. I mean, I went in Thursday afternoon. I hear about the test on Saturday, so I go in there and I take the novice or the first two levels, technician and general, and I take the test on Saturday and pass with flying colors. Then I spent the next month working through over and over again the extra class, and then took that a month later and got that. So that was the process for coming back on. It was interesting. But I didn't have a station at that point. Again, my same friend, he was the one that told me about the IC7300, which was being announced at that point. So being a DSP guy, I was very interested in reading the details about their SDR technology. Very, very interested. And I said, this is the wave of the future. This is the change. Everybody's going to be doing this. This is the first of the. So I wanted to buy. I did. I bought one. It was $1,500. Because it was first one off the chute almost. Right. It is. It is. It was a groundbreaking event for that machine. For them to do what they did, it was an ingenious combination of technology. At that point, I was living in a place where I was able to put up a inverted V. I think it was for 40 meters, and was on the air. Mostly, I didn't do any CW, by the way. I had my first experience with CW was with my father looking over my shoulder and me sweating bullets and forgetting what word I was in, what's the next letter of the word. Then I get to the end of the word, and it's like, what was the sentence? I was flying the sun. And it was such a horrible experience. I never went back on the air as a CW again, using a straight key. So, but I did a lot of single sideband.
Did you get back into ham radio like in your retirement years, or was this like pre-retirement and you'd moved to Idaho, and were you still working at that point before you started the business that we'll talk about in a few minutes?
Well, it was semi-retirement. I was still on the payroll, or let's say a retainer from the company when Apple spun us out into a company called FlashPoint Technology. That we did cameras for Kodak and HP and Minolta and a few other companies before 2000 market collapse, which kind of killed us off. But they kept on doing the intellectual property stuff, which I was involved in as the inventor. And so they were suing companies and getting big payments, and they had to have me on the payroll because I might somebody might come along and pay me to be on the other side as a witness. So I was paid pretty well for, 15 years, just to virtually do nothing. I think I worked maybe a month total for 15 years. And so I was pretty happy with that. But then the Congress changed the rules. I don't know what year it was. I think it was 2015, 14, which tipped the scales for patents towards big companies so badly that there's no point in having a patent if you're a small company. It's not worth it. So they couldn't afford to do anything anymore, so they shut down and stopped paying me. So you could say I was retired because I had a company called Anderson Creations where I was doing intellectual property work for other companies. I would go into companies and sit down with their engineering staff, and I would extract inventions. What I mean by that is most engineers don't know they invented things because they worked on it for 3 months, figured it out, and are building it, and to them it's obvious, right? I mean, it's obvious, seriously. But the problem is it wasn't obvious to anybody else, and that's why they took 3 months to figure it out. That's an invention. So we would go and extract that, because I had a lot of experience at Apple. I mean, we basically were involved in the startup of the intellectual property operation at Apple, because Steve Jobs, when he was there first time, he didn't believe in patents. So there was no patenting going on until when he came back. Of course, he did believe in patents, but he had learned his lesson at next. So I was involved in that startup at Apple. It's pretty interesting. So I knew a lot about the patent process and how engineers don't know. And I would do that. I did that at Apple. I would get patents out of my own team doing that same process. So I was doing that, and I was doing other kinds of technology stuff for people. And I was also acting as a witness, of course, for like Apple, for example, getting paid fairly big bucks to be a witness, because I was the only person, I was the only person in the universe that knew the answers to the questions that were being asked. So about the projects that we were doing back in the day.
I myself actually have a patent on something, but after that whole process, as a small company, the idea that seemed to be popular in my mind at the time, perhaps it wasn't popular amongst anybody else, is that, I was small and agile and could move pretty fast, but I could never afford to defend a patent against a large company. So it seemed that my only advantage was being fast and nimble.
That's correct. Basically, people think that a patent protects you. It doesn't protect you. It gives you the right to sue somebody or the right to defend yourself. That's it. So, for example, if somebody else is copying you, and if you have a bigger legal department than they do,
right.
But you have to have the bigger legal department. Otherwise, forget it.
If you were a small entrepreneur, you couldn't pay your legal fees to even entertain a hearing.
Exactly. You'd have to have a lawyer to at least write a threatening letter. And then, of course, they would ignore that if they checked out how big you were, because there's no way that you're going to overpower their legal team. They would just beat you to death. And so that's exactly correct. That's why we don't do patents now. We did them at Apple, and Apple, by the way, didn't enforce patents. They didn't go after people for patents. I mean, FlashPoint Technology did, but they used it only as defense, or trade. So, for example, if they needed a patent from Intel, they would trade a patent on, say, digital cameras for a patent on some aspect of a computer system. And so cross-licensing was the way that Apple used the patents for expanding their reach in terms of what technology they could use and so forth. So that's really, but technology, FlashPoint Technology was very aggressive in pursuing companies that were using their technology. And by the way, the biggest lawsuit I was involved in was Kodak against Apple. And it turns out, and it was $1 billion lawsuit. They wanted $1 billion from Apple. They had already gotten $1 billion by suing a whole bunch of other companies, the last of which, before they sued Apple, was Samsung for $300 million. And it turned out the patent that they had was stolen from me. I didn't, of course, realize that. I mean, there were so many inventions going on. And we had this forced relationship with Kodak. They picked out 10 things that we failed to file, right? Because we had 150 filings, so many filings. It was like ridiculous. And so they filed 10 of my ideas and got 10 patents, 11 patents actually. And then they went around suing people for one of them, which turned out to be very valuable. And when they came up against Apple hired me to be their star witness. It was quite a gig, I'll tell you. I mean, it was quite a gig. I, of course, was only in the trial room when I was on the stand. And of course, the questions that were asked me were sometimes very ridiculous and stupid, but they were trying to unnerve me and trying to get me upset. And my lawyers told me, you were like in Zen, you were sitting there in Zen. And I said, well, I was. I mean, I was totally focused on the screen in front of me, the microphone, listening and answering. I was not looking around. I didn't notice the Kodak lawyer jumping up and down and waving his arms to try to get my attention. I was just in Zen mode. But afterwards, this trial was over. This is all Washington, D.C. at the International Trade Commission. So they come they invite me to dinner to celebrate. That's when they told me, they said, we had the other guy that you worked with at Kodak, we had him on the stand, and he was so badly, we got him so bad. You should have seen him sweating and squirming. It was unbelievable. It was so amazing to see him sit there, and we caught him in so many lies. I said, boy, I wish I had been a fly on the wall to see that. But they had managed to extract from Kodak all the notebooks, his notebooks. All the previous companies had only been able to get 3 pages. Apple insisted, we want the entire notebook. And they were able to track with all the documentation I had done and all of that, every meeting we had with Kodak, and when I had written a document, and when I had handed it over, a copy of it over to Kodak, because they were building the product, we were designing and developing the product. Our response was the design of the operating system and the feature set and the application and all the hardware design and all that kind of stuff. They were responsible for the camera software. They traced down exactly when I wrote a particular document that had the idea in it, and when I handed it off to them during what meeting, and it even said on the document that they had their copy of it. It said, received from Eric Anderson on this date. It was like they trapped them so bad. It was incredible. So they ended up invalidating that patent. And you imagine being Samsung at that point. We just paid $300 million for an invalid patent.
That was painful.
Oh, my gosh, yeah.
I want to take a minute to tell you about my favorite podcast, the Ham Radio Workbench Podcast, with George, KJ6VU, and now joined by Rod, VA3ON, Mike, VA3MW, Mark, N6MTS, and Vince, VE6LK. Every 2 weeks, George and company offer up a status report on the many amateur radio projects on their workbenches and explore projects on their guests' workbenches. This group is project active and prolific, covering many technical areas of amateur radio. So the next time you want a deep dive into ham radio electronic project building, or to learn about technology, tools, test equipment, construction techniques, and the rest, listen to the Ham Radio Workbench podcast, available on every podcast player and channel. Use the link in this week's show notes page to get to the Ham Radio Workbench podcast directly. And now back to my QSO. Eric, we met because you have a company called Preppcomm, and you have graciously come to the QSO Today Virtual Ham Expo now, I think 3 times, and we're coming up on a 4th. Can you talk a little bit about Preppcomm? You had an unusual problem, I think, that you wanted to solve in ham radio. Could you talk about what the problem was and how you solved the problem? Yeah.
Up here in northern Idaho, it's called the Redoubt. Don't ask me where that came from, but there's even a website called Redoubt News and stuff like that. It's basically considered to be a place of safety in the coming storm. And so we have people come here under the idea that this place somehow is going to be safe when everything else burns. I don't know if there's any truth to that, but people feel like God is calling them here. So who knows? Maybe it is, maybe it isn't. But so there's a lot of preppers here, and we got involved. I've been I was a prepper before I came here, and the problem I was having before was I didn't have any place to put stuff, and so I got here and I had plenty of place to put stuff, and we did a whole setup in our previous home. One of the things I noticed, preppers are, what they do, right, is to have a lot of stuff to prepare for if things go bad. Like the power grid goes down, the internet goes down, whatever. Things are, the normal services that we rely on every day suddenly are not available.
Like food shortages or water shortage, any kind of shortage that leaves the population without.
There you go. So they have water filters and water supplies, and they have food supplies, freeze-dried, typically food supplies, typically for a year or 2 years or whatever. And they have guns, of course, and ammo, because they figure people are going to try to steal it, which is, I'm sure, is true if that event actually happens. What were they doing for communication? Well, they had VHF, UHF, Baofeng, $35 handheld radios, conveniently supplied to them at low cost by the Communist Party, CCP. They're the ones, they actually, believe it or not, they actually supply those at a low price through Baofeng. You have to ask the question, why are they doing that? That's a very good question. But these guys, the preppers don't seem to care about that. And so they use those to communicate via relays or repeaters up on the mountaintops. And there's plenty of mountaintops here in Idaho. So we even have a North Idaho repeater network up here, which I've been involved in and have supported financially and that kind of stuff. Even helped repair some of the equipment. So the problem with that is, of course, let's start with the pros. The pros of that is the equipment is cheap. It's easy to operate, assuming you have somebody else program it for you, because typically the person that buys one of those has no clue how to operate it or program it, but somebody else will then plug it into their computer, upload a file into it, and now they can say, okay, so has all the channels for the repeaters nearby. So which is a very nice service. So now they have a handheld that they can talk to 3 or 4 repeaters or 10 repeaters, whatever, and maybe the weather and other stuff. So it's very convenient. It's easy. You can just use your voice. So that's what they use. They all get a technician class license because they're not really interested in ham radio per se. I mean, if they could do that with a FMS, they would do it. They wouldn't get a license at all. Most of them. It's not true of all of them, but a lot of them would just use FMS or
GMRS.
Yeah, if they could do that without getting a license. So I looked at that and I said to myself, that's not really it's not really a survivable approach to communication, because what's going to happen if the grid goes down? What's going to happen if there's an earthquake? The earthquake's going to take down the tower, or the grid's going to go down and there's nobody to go up there and start the generator, or there is no generator. I mean, there's all kinds of reasons. I mean, our repeater goes down all by itself. And it doesn't need any help. Or it goes down usually just after you've had a huge snowfall and you can't get up there. So it's down for the entire winter. That happened twice since I've been here. So, it's not a reliable infrastructure that you can depend on, which doesn't make any sense for a prepper. So I said, okay, why don't we solve that problem? Well, what's the problem there? HF is a solution, a solution, that because it has the reach anywhere from local to international, it has the negative of you have to have an antenna, right? You can't use a rubber ducky. It has the negative of you actually have to learn how to use you have to learn things like, if the band is only open from, this time to this time or whatever. You have to learn a lot of stuff. You can't just push a button and talk. Okay, so there's a lot of negatives. And, hey, our transceiver is not cheap compared to a $35 Baofeng. But we didn't know that. We didn't think about that. We thought this is the solution. We have a unit that they don't have to learn Morse code because that's the big killer. They don't want to learn Morse code. And we didn't realize there was the other killers, which was, I don't want to put up an antenna, and I don't want to have to learn how to use something on HF, and blah, 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 blah. Anyway, so we thought, if we solve the problem for Morse code, and they all have, technician class licenses, then this would be a solution for that particular market.
Why Morse code and not RIDI, for example, if you were trying to make a prepper HF communications terminal?
Well, maybe I don't know the law as well as I think I do, but the thing that you have to do to be on HF, if you have a technician class license, is Morse code. There's no option for RIDI or PSK31. There's a lot of pressure to add that, but they haven't done it.
I see. So if they have a technician class license, they have very limited HF privileges, and that's around Morse code, kind of like the novice had in the novice days.
Yeah, they only can operate on, I think, 40, 80, and 20.
And 15. 40, 80, and 15?
Something like that, yeah. I don't think they can do, they can't operate on 20, which is brings up another interesting story about testing our rig and discovering it's not working, because it was set to technician level, And of course, it doesn't work for technicians on 20. And we were thinking, oh, it's broken. And then we remembered, oh, I have to set it to a higher higher level. Anyway, that's one of our features, is that you can set the transceiver, tell it what license level you have, and then it will prevent you from operating where you're not supposed to. So we forgot they couldn't operate at 20 meters when we were testing it in the manufacturing area, and thought it was broken. And it actually wasn't broken at all. It was saying, no, you can't. Sorry, you can't broadcast on 20 meters.
Just so I can reframe the problem you had is you wanted a prepper radio that would work under all conditions, that wasn't relying on an intermediate system like a repeater.
Right.
That was designed for the technician class licensee who could only operate CW in the HF bands.
There you go. It wasn't limited, obviously, to just technicians.
But for the technician, this would be the rig.
Right. This would open up HF for them. And so we started developing it. We got about halfway through the project. We had the decoder working very well from a key, just a key input, which was actually two pieces of wire being touched together in the lab by me. We developed the hand algorithm and the speed algorithm and the entire decoding scheme with the table lookups and all that kinds of stuff. The timing junk was all working great. Then we said, okay, let's put the front end in so we could then decode off the air. So we built the front end, which is just basically a little bit of audio processing, not much, and a chip that everybody uses to convert tones into digital signals. And we plugged it into our 7300 and couldn't decode anything. I mean, nothing decoded at all. It was like, wait a minute, what's going on? What's wrong with this circuit? Now, the LED was blinking, and it looked like it was decoding from that point of view, but the output was zip. So we got out our oscilloscope and our logic analyzer and discovered the obvious, that there was a lot of noise on the band, and the noise was causing the DAWs to have, splotches in them, so they weren't continuous, and some of the dits got missed, or they were splotchy as well, or there was splotchy and mixed together with the next dit. It was kind of a mess, and so we understood, oh my gosh, this is a much worse problem than we thought. I mean, we didn't realize this was a problem. We thought the problem was, just turning on and off into visible text on a screen. So we messed around with that for about a month. We said, if we can't solve this problem, I guess the project is over, because if we can't decode reliably off the air with noise in the signal, we're done. Little did I know at the time that that's exactly what most people were selling. I didn't know that. So I found that out later from my customers. Anyway, at one point, I prayed about this. I'm a believer. I'm a Christian. So I prayed about it and asked God for a solution, because I had worked for, a year or so, a year and a half on this project already. And this was one of the final pieces. And it was looking like I wasted my entire time. At one point, this idea popped into my head. The thing that's interesting about ideas that you get, what I believe are from God, is they're complete. It's not like a germ of an idea. It's the whole solution. And so I don't know if that's always true, but that's certainly been the case for me a number of times. So I said, well, gee, I'll try implementing it. I don't know. Who knows, So I went in and wrote the DSP code. It actually can run on an Arduino, so it's not super heavy duty. Plugged it in, ran it, and connected up my IC7300 and tuned in a signal, and it worked the first time. It was like, what? It working the first time. I tried to adjust it, and it made it worse. So it turned out that it was, the only thing I ended up adjusting a little bit was the analog front end, and to actually make the signal worse. It's kind of weird. It turns out making the signal noisier makes the noise separator work better. So the DSP is essentially separating noise from signal. And if there's more noise, then it's actually better for separating it from the signal than if there's less noise. Of course, if there's no noise, it works just fine. But if you're, in general, if there's noise, it's better to have more of it than less of it, which is weird. I don't understand that either. Don't ask me to explain that, because I can't. So anyway, once that was done, I got the unit out and discovered locally, when we were already selling it locally, and local ham clubs and that kind of stuff, that the prepper community really wasn't interested. It was too hard. It wasn't push the button and talk. We have had times, and since I've been here, where the repeater has been useless during emergencies. Why? Because either it wasn't there or it was totally overloaded because everybody was trying to talk on it. And in both cases, a complete wipeout. No use at all. All the equipment and all the plans for how to respond to fires and stuff like that went down the tubes because they're not workable. People will not shut their mouth and only let people who need to talk. It just doesn't work that way. So because it's all one frequency, and you have one frequency that everybody has to go on. And when you have an emergency, everybody's going to go to that frequency, and it all falls apart.
You have to have somebody become the net control and manage the channel.
And you have to have obedient users that are not freaking out and scared their house is on fire or something. That's... Do
you think that northern Idaho hams are different than hams in other places?
No, I think that would be true anywhere. That's the problem with the single, the repeater system. If there's one repeater and there's a big emergency,
right,
that's going to die. You're going to have other methods for communicating.
No, I guess what I'm saying is it seems to me that the guy that becomes the self-appointed net control operator, and because he has a strong personality and an ability to manage a situation, that kind of makes that single channel become more useful. But I'm interested, when you came to the expo the first time and you were talking about your Preppcomm company and this product, you were literally making the product in your garage or in your house. You were actually printing the cases on your own 3D printer. I could imagine the operation. How has the operation at Preppcomm, how has that evolved since last year, I guess?
Yeah, it's only a year and a little bit over a year ago, year and a half. Well, actually, it's interesting that the QSO Today Virtual Ham Expo was our launching pad. Before that, we had sold a number of units locally. We had sold some pre-production units. We had sold some production units. And we, had of course, our website was up. And I don't remember when we started advertising in QST. But, we had a few sales, not very many. And when we launched at QSO Today in March of 2021, that was really where a number of people heard about us. Before that, we were unknown, totally unknown. Now we're still unknown pretty much, but less unknown than we were then. How do I know we're unknown still? Well, we had CPAC is a show here in Oregon on the ocean side every year, so Hamfest. And when we called up to register for a booth, they said, "Who are you?" And we said, "Preppcomm." And they said, "Who's that?" So yeah, we're still unknown. But what's changed? Well, we're still when back then I was making the products myself, and my wife was helping me. We could make 8 units in one day. Now, when I say make them, that's not the whole story, because then you have to test them, of course, and then you have to box them up and ship them. So really, you have to say we can make 4 a day, because the next day you'd have to test them and then box them up and ship them. So that's where we were when we first announced at QSO Today, and we got a fair number of orders, and it kept us pretty busy. So we managed to then find somebody. Actually, it was because of QSO Today. So let me explain how that happened. So one of the guys in our local club, who was it's a good friend of mine, he's not actually involved in the company per se, although now he's making antennas for us and working on 3D for products in the future. He wasn't that involved, but he was going to help be a person, for people to talk to on QSO Today. So I was talking to him in the room that, before the show opened. So we were testing the system out, and his wife was sitting behind him. And at one point, she says, "Hey, I've done customer service," raising her hand, and everything, because it was video. So I asked her later, I said, "Would you be interested in learning how to assemble these products?" And she said, "Yeah." So she came over. We taught her. It turns out she was a magnet. she could learn how to do stuff very quickly. So she actually became our primary worker for quite a long time. She learned how to assemble them, how to test them, how to box and ship them. You taught her the inventory system, so she does inventory. She does ordering now, and she does some other stuff, not related to. But we have boxes stacked up around the manufactory, which is a one bedroom, and the lab is, which I'm sitting in now, is the other bedroom. So we have about 300 square feet, and it's getting pretty dense because of the inventory.
We will return to our guests in just a moment. A new way to show your support of the QSO Today podcast is to buy me a coffee. I consume gallons of coffee to create this weekly podcast. Invite me for coffee by pushing the yellow button, Buy Me a Coffee, on the QSO Today show notes page. And now back to our QSO Today. Now that we've spoken for over an hour and you've given me your background, now I understand why you were so confident in that first expo that you came to. That was the March 2021, where I was trying to merge the AirMeet platform with the vFairs platform, and it all unraveled very quickly for the people that were kind of marginally familiar with how to work these things. But you were doing something very interesting. You were in one of those tables, but you had logged in with your phone, I think, at another place at the table, and you were actually doing demonstrations using the phone. The phone was your camera in your hand that you were using to show the rig and how it worked. And at the time, I thought that was so clever. But now that we've spoken, now I understand why you are so savvy with using the phone in this way.
Well, it's an interesting. We did a bunch of videos. I don't know. I think we did them after that, which are on YouTube. For the first product, the DMX40, it was at the second show in August, where we had a giveaway of a DMX40, but you had to sign up for it on our booth. You had to fill out a questionnaire. We didn't do this the first time, but the second time we did, and it was a pretty long questionnaire about what bands did you use, and a whole bunch of stuff. And we even had one complaint. Why do I have to fill out a questionnaire? But we learned a lot of stuff from it. And one of the number one things was we want multiple bands. One band is not enough. So that's why we came out with the MMX this year, which was, has 3 bands, as an option of up to 3 bands, plug-in concept.
And what does MMX stand for?
Multi-band Morris transceiver. M for multiband and X for transceiver. So, yeah, that we learned a lot of interesting stuff. People are still demanding a 15-meter plug-in card, so we'll probably do that in the future. I guess 80 meters isn't very popular. We have 80, 40, and 20 right now, so I think if we add 15, we'll have a lot of 40, 20, 15 products. Right now, the most popular configuration is actually 80, 40, 20, and the second most popular is 40, 20. I bet you if we had a 15-meter card option, the number 1 would be 40, 20, 15, and number 2 would be 80, 40, 20.
Do you think the warp bands are interesting for this? 30 meters, 17 meters?
I don't know. I mean, I look at those bands, and to me, they're kind of out in outer space. I mean, I've tuned into them and thought, geez, I don't know, this is nothing here. Probably when the band was dead. I don't know.
I get that. I mean, I tune around with my 7300, and I always end up back on 20. I don't know why. Maybe because there just seems to be there's more action on 20 when I happen to be listening.
Yeah, that's true.
Before we wrap up Preppcomm, and again, I'm so excited that the expo was helpful in getting Preppcomm started. What are you finding? I mean, in terms of the people that are buying this kind of transceiver, this ability to be on CW without necessarily learning the code. What are you learning from that? What are you learning from your customers?
There's a number of things. So one thing was, we had hoped this was true, but we didn't know. I mean, there's a theory about cognitive association. And I was telling people about the theory because, the basic idea there is if you hear the code and you see the code decoded, your brain will associate that automatically for you. You don't have to work at it. Nice theory. Is it true? Well, I've had several customers who have told me, yes, it is true. That after 2 or 3 months of using their DMX40, they were beginning to think the letter before they saw it on the screen. That was pretty impressive. A second thing they learned, so we have 2 modes called the HCW mode, which is human CW, That's where we try to figure out how fast are they going and try to track their speed and what is their hand, how long are their dits, how long are their DAWs, how much space do they use, and all this kind of stuff. We have 5 different values that we calculate for each person that we're receiving. With this other mode, it's called CTX for computer texting, and that assumes that the other station is sending on a known speed and is sending perfect code. And believe me, that makes a big difference in terms of the ability to decode it, because you know perfectly what exactly what the timing is. They're not synchronized. You don't have the same clock, but you do know, the timing. And so I didn't do much with that because once I got HCW working, I figured, well, who's going to use CTX because you have to have the other station. The other station has to be on it as well. Well, guess what? We have some customers that use CTX because it's better. Well, I was surprised. I didn't think anybody would use it. So now we have plans to enhance CTX. So it's much better than it is now, and it's very early stage. And we have actually worked talking with a professor at the Case Western University who has developed with his students some technology that's actually been around since the 1920s, but they're enhancing it, and it's called, what is it called? I'll think of the term in a second, but it's basically relies on having a common time base. So it's not just that you know the timing of the signal, but you actually know when the DIT is supposed to start and when the DAW is supposed to start, when they're supposed to end. It's called, I still can't think of the name, but it'll come to me. But anyway, the way they synchronize, the way they used to do it in the 1920s is they would send a whole bunch of DITs in a row so that the other side could essentially synchronize their clock, right? Then they would send the code. And then in the 1990s, some people were screwing around with it as well, that idea, but it didn't go anywhere. He wants to get us to put it in future rigs because basically his experience with what they've developed is it's almost as good as FT8, but it's CW. So there's no limitations of you got to have this, a certain amount of time here, block, and you have another block, that kind of nonsense.
Or using GPS locking, for example, to make sure that you're in the right exact time window.
Right, none of that. You don't need a computer. He uses GPS, so we would be putting a GPS chip in our units, or have it as a plug-in. And this is I still can't think of the word. It starts with a C. But anyway, that would be the top level. So we want to have at least 2 or 3 levels of what you call it, security or quality of transmission and reception. The base being in the current CTX, the next one up being an enhanced CTX, and the next level up being this third method where you have to have a common time base through GPS. So if we can achieve that, that's where our goal is.
Can you create a fist from sending, meaning that can you weight the DAWs and dashes so that it doesn't sound like a machine is sending the code?
Of course you could. Why would you want to do that?
I don't know, so that you might have a unique sound on the air, like some people who send kind of a unique sound?
Well, I mean, if there was a market for it, we could do it. I don't see that there being a market for that. I mean, it's a cool idea, but and anybody could do that if they built a transfer. I mean, if you write a program on, so one of the things that's interesting about CTX is it would be very easy to write a computer program to do CTX. I mean, it's nothing to it, right? I mean, you have to send at a certain speed and you have to receive at that certain speed, and it makes the decoder very simple, relatively speaking. You still have noise issues. So that's the other issue that you can't get around the noise issue. If your decoder can't handle noise, you're going to be dead no matter what. So the combination of the noise suppression system that we have and CTX, and then you add on this other system with a GPS, we believe that we'll be able to come very close to FT8. I mean, I was listening the other day to a station. It was fading in and out on my MMX here in the lab, and I couldn't hear it. But the CW inlight was still blinking. It was like, and it was decoding. It was like, I mean, I remember it doing that in the past, and it always blew my mind when it was doing that. It's like, I can't hear it. I can't hear the signal, but it is still hearing the signal under the noise, and it's decoding it. So that's what it can do now. But with this other system that we hope to implement in the next product line, it should improve our ability to where you can transmit and be heard almost anywhere very reliably. So at least that's what they're telling me. They've done a lot of tests with this system, and they've been able to establish its abilities in terms of ability to transmit under heavy noise conditions and over long distances, very weak signals. So, which is what FT8 is known for.
Are you able to field upgrade the firmware in your transceivers? If you have a new firmware release, can you send that out to current users of the product?
No, unfortunately not. But that will be something we will be introducing the next time. What we call over-the-air upgrades. There will also be ability to do over-the-air upgrades on a unit-by-unit basis. So, for example, if we chose to have a feature that we wanted to charge for, you could say, okay, you bought it, so we send you the code, and nobody else can run that code. So that will be something that will be included. So you can either send out a universal code, which anybody using that unit could use, or you can send out a very specific code for that particular user. And it's also, the processor we're going to be using actually runs encrypted code natively. In other words, it doesn't, it's hard to believe this, but the instruction set, which is hidden inside the processor, it doesn't, you never see that because it's actually executing encrypted code. So if you looked at what it's executing, it's all encrypted. You can't even see what the code is. So if you actually get the code on the chip, it's encrypted. I find that hard to believe that you have a 64-bit or whatever it is, 128-bit encryption system that's so fast that it can run at 240 megahertz clock rate, single cycle instructions. I mean, it's like, you got to be kidding me. But that's what they have. So that's what we're going to be using, and it's a much better processor. When we first started this project with our dual Arduinos and the ARM chip, they didn't have that chip. They do now.
How are supply chain issues affecting you right now?
Oh man, that's a sore subject. We actually have in-house probably at least 300 sets of boards for MMXs. The reason we have that many in-house instead of necessarily 100 or something is because of the supply base issues that we were experiencing, and we bought up ahead. The processors, we use 3 different processors, and 2 processors, which are Arduino chips, usually they used to sell for $1.95, and they went up to $50 each. We managed to get them at $26 for a bunch of boards, and I think $15 for a bunch of boards, because we didn't want to wait and get them at 50 or not available at all. We actually couldn't build boards for a while because there were certain chips weren't available. Just plain couldn't get them. In the transceiver, for example, there were several chips, and I can't get parts for the transceiver today. I mean, so I go out and say I want to get replacements for the final amp transistors. They're not available. If I want to get a replacement for the driver, the power supply chip, not the power supply chip, but the chip. There's a PNP transistor that provides the power to the power amplifiers, which is driven by the key shaping, and that guy isn't available. A lot of stuff isn't available now, and the only reason we're able to ship product is because we bought a whole pile of stuff in February. I mean, we bought like 500 boards or something. I don't know. Yeah, 500 boards or 500 sets of. We bought a bunch of components and had the printed circuit board company stock them for us so that we could build another round of a couple hundred boards. I guess it was in March or April. So we built essentially 500 boards up ahead of time.
Eric, do you find that the supply chain is improving, or is it kind of vacillating?
It's still very spotty. I mean, I got a quote the other day from a company that said they could sell me these chips for, I guess it was $2.35. Well, it turns out, they ordered 500 of them, and they're supposed to get them in 6 months. Okay, that's not really available.
Yeah, no, I see that on Mauser and DigiKey and stuff where they anticipate having whatever it is, in 6 months.
Well, this all started for us back in the fall of last year when we couldn't get the primary the frequency control system, the digital frequency synthesizer chip that is the heart of the transmitter and receiver. That chip became unavailable, and we go to Mauser and DigiKey, and they both said it'd be available by September of this year, right?
Right.
Well, without that chip, we're out of business. So, there's a lot of chips, unfortunately, that if we don't have, we're out of business. That one was absolute. You couldn't program around it. You couldn't redesign a board around some other chip because there isn't any other chip that does that. I don't know why not. But so we did some investigation, found out that the company that made it was bought by a Chinese company, shut down, people laid off, and all this stuff was boxed up and sent to China. And someday they'll unbox it and set it up and make some more other chips. Some days, I guess, I don't know if that's happened yet or not. I know that you still can get small quantities of that chip. So we went to our supplier, and the PC board. We do turnkey, which means they do everything. They order the parts, they inventory the parts, they build the circuit boards, and then they assemble them and do the soldering and a whole bit. It's a lot cheaper that way. We used to spend hours and hours and hours and hours doing that stuff ourselves, and it still costs us more money, plus all the hours. So now it's a turnkey. But anyway, they went out and found somebody that had 1,000 of them, and they said we can get them for $6.50 for 1,000. But the offer is for today only, because tomorrow we don't know if the parts will still be there, and we don't know what the price will be. So I said, okay. I mean, we got to get the whole team together. At that point, that was a fairly big chunk of money. This was last November, and less of a chunk today, but it's still a big chunk. And we prayed about it and talked about it and decided, okay, we're going to go for it. So we sent them an email, said, we'll send you the money, we'll wire the money tomorrow. So they got them for us, and we stayed in business. That's how it started. And we didn't realize at that point that we were going to run out of 7 or 8 chips that we weren't going to be able to get in February. So it's been, and I would say no, it's still not good. I still can't get the parts I want when I want them. So I would say, it's not anywhere near where it should be. And I don't think it's artificial. In other words, I don't know what's really going on. I'm not a genius here on what's going on in the world, but there's no excuse for what's happening. So somebody's doing it on purpose.
I think it also makes us think that perhaps America should have its foundries back.
Absolutely.
That America should be making its own components, especially those components that are essential to the protection and safety of the country.
Come on, you got to have resistors and capacitors.
Right.
I mean, sure, you might have the most important, chip in your missile, but if you don't have resistors and capacitors, you can't use it.
Right. No, this is exactly right. Eric, what do you think the greatest challenge facing amateur radio is now that you're back in and you're kind of working with the hams?
I think it's the problem of the cell phone. I think the getting younger people into ham radio is a challenge because, let's face it, I mean, now you can talk to anybody you want just by picking up your cell phone, which is also your camera and your game machine and, everything else. And you can talk to anybody you want. Anywhere in the world, oftentimes without any charge. I mean, other than what your normal monthly bill is. So what do you need ham radio for, right? So the idea of ham radio has to be better explain the excitement of being on the air with, say, for example, 100 milliwatts and talking to somebody in China, or I don't know, you probably can't talk to people in China. So, some distant place, Japan, England, on 100 milliwatts on CW, or there's all kinds of possibilities that can be, but you have to have the right environment to teach them and show them why that's fun. It's hard to compete with all these games they have, right? I mean, they're very intense The games are very intense, very instant, and they're very, you don't have to, they make sure that you never lose focus because something's always happening.
I'm going to kind of play the devil's advocate here. I hear what you're saying on the one hand, and yet you've kind of like put yourself way out on the ledge creating an amateur radio product. On the one hand, yes, I think, it's hard to compete with cell phones. But a guy like you who's buying 10,000 chips or 1,000 chips, because that's a real commitment towards making more product, you must have a message that you could give to these young people that would differentiate ham radio from their cell phone, even as a member of the prepper community.
The simple message is it works even when the government takes away your cell phone. So, or the power goes down, when the grid goes down because there's an earthquake, or because there's a nuclear explosion somewhere, or because there's an attack on some power grid station somewhere and your grid goes down, or you just have a big hurricane. I mean, there's all kinds of ways.
Right. We have all kinds of examples of the grid going down.
Now you have no communication because your cell phone is dead. Long live your cell phone. And sure, you can still play games on it, but you can't talk to anybody anymore. So what we have is something that if you learn how to use it, you can still contact people. You can contact and have a ham call your parents or your uncle or whatever and tell them that you're okay, or that you don't have any food or whatever. You can do that. That's one of the. The other message is it's really cool. I mean, this is not just a ham radio. This is a computer system that's got very cool features and does stuff that's really cool. I mean, something as simple as you're tuning in another station and it picks up their call sign automatically and it shows it up on the screen. And then when you answer them, guess what? It uses your call sign and their call sign to do the station ID automatically. You don't have to remember their call sign. You don't have to remember to type it right. Guess what? It's already in the system. It's already doing it for you. There's all kinds of stuff that our rig does that makes it very easy to get into it and enjoy it. And then, of course, you have the ability, if you're wanting to get into more into it, we have RPL, Rig Programming Language, which is the most powerful, quote-unquote, macro language out there, is you can program it to do whatever you want. So instead of using the built-in functions of doing station IDs and back and forth and doing calling CQs and calling other stations, those are all built in. Info macro is built in, but you can also, change the rules and use function keys to make the transmitter do whatever you want it to do, transmit whatever you want. Just turn it on and off, for example, so you do everything on the keyboard, or you do everything with your key, or you can mix it. You can have a key, or you can have a keyboard, or both. The thing that's unique about our system is between the learning of the code, even if you don't want to learn the code, you still learn it because of the cognitive association. You can't really turn that off. That's just how your brain works. But because I can guarantee you what you're doing is you're looking at the screen and you're hearing the code. I mean, it's just the way it is, right? But on the transmit side, not so easy. You do have to practice. And we help that even there, because when the transceiver is in receive mode, the decoder is still available, and it's available through the key in. So you can actually key in to the decoder. So the decoder then is acting like another ham listening to what you're sending, and it's telling you what it thinks you sent on the screen.
So it'll improve your code you're sending, right? Because you're seeing what you're sending.
Yeah. Well, you hope you're seeing what you're sending.
Yeah. So, Eric, what advice would you give to newer returning hams to the hobby? You've come back. You're kind of a returnee. But what would you say to newer returning hams that want to come back into amateur radio or want to join amateur radio? What would you suggest they do?
Well, it's interesting. One of the things I didn't mention about customers. So when I'm sitting in a booth, like in CPAC, for example, and somebody comes walking by, they're not looking for us. They've never heard of us. They're walking by, and they notice, we have something to do with ham radio, because it says on the sign, Preppcomm amateur radio. And then they look at they take a glance at the product, and then they see a Morse code somewhere, somewhere on the booth, and it pings them like, I've always wanted to get into Morse code. I just never could do it, or never had the time. Or when I was Eagle Scout, I did, Morse code, but I haven't done anything with it yet. I really love to get back to Morse code. I mean, I get a lot of that. Older people who have always wanted to go into Morse code, but never could, either because of a time or they're not, they just can't do it at fast enough speed, or sometimes it's a limitation. They can't use a key because they got the shakes, or they can't hear very well, or there's all kinds of reasons. But they come in and they say, "Wow, this is incredible! I can get back on the air with CW. I've always wanted to do that." It's like, yeah, that's exactly right. I mean, that's in fact the hearing impaired, the physically impaired is one of our markets, because it gives them the ability to be on the air and have QSOs, even though they're in their impaired state, where they're pretty much cut off under normal circumstances. So that's one of the things that can be done. But for a normal person, if they've been in ham radio before, they often have I don't know why, they just have this desire to always wanted to be able to use CW, but couldn't do it. And now they can. And it's like, oh, this is like, so here's a guy who just came by the booth, never heard of us, wasn't looking for the product, saw the product, tripped over it essentially, and, oh, I want one, right? We did an interview on YouTube a couple of weeks ago, a month ago, and during the interview, there was two guys besides the interviewer who were there. I guess they were sidekicks that usually were there, and start showing them, and it wasn't working. And the reason it wasn't working was because it was stuck in CTX mode, and I didn't notice it. So finally, I noticed it. I said, "Hey, it's in CTX mode." I hit escape to take it out of CTX mode. So they did, and it immediately started decoding. And one of the guys said, "I want one," and so he actually bought one right on the spot. And I'm on video, right? And so my phone, my watch goes ding, and it's a big Shopify thing on the watch. And I said, "Well, look at that! He just bought one." I mean, it was really hilarious, because it's just magical to see it work. I mean, it really is.
Maybe you can confirm this, but I think this romantic idea that CW is unique. It's unique to amateur radio operators, but that also that it's an elite club on amateur radio, unlike, single sideband and the upper ends of the bands. Down at the lower end, the CW operators are a unique club, are unique operators. Do you think that's part of the romance of CW?
I think so, because, see, really, when you think about it, a single sideband or any voice-type communication, or even really any digital mode, you don't really have to do much. I mean, you buy the equipment and you use it, right? You buy the equipment and you use it. To do CW, even with our rig, is not straightforward. I mean, you have to learn a bunch of stuff, like, for example, one of the problems I had early days was I would tune into a strong signal and I would get gibberish, and I would think, oh no, the decoder isn't working after all. And I would take a copy of that signal and off the radio along with what the decoder was doing. I would discover, yes, this decoder is working perfectly. I don't know what the crap this is. I still don't know. I still run into those stations and I don't know what the crap it is. Or you run into a couple of hams talking back and forth, and it's also partially gibberish. You see a bunch of English words and non-English words in between. And it's abbreviations. And you don't know what the crap the abbreviations are. You have to learn them. And of course, once you learn them, you'll probably use them too. But you have to learn stuff. I mean, even though it's very simple to operate, you have to tune around. You have to find the station. You have to know when to do that. What are the bands? What are they open? You have to have an antenna that you put up that you have to know, how to do that. You have to know a lot of stuff. You have to learn and practice to use our rig successfully. It has to take some practice. It's not like just, tuning into a PSK31 and just type. That's very easy. PSK31 is very easy, not like CW. So yes, it does have there's a price you have to pay to enter that club. You can't just enter it and just say, "Oh yeah, hi, how you guys doing over here?" It doesn't work that way.
Right, and the price to pay isn't just money. The price to pay is a commitment to learning new skills.
Yes, exactly. It doesn't take hardly any learning to push a button on your microphone and then say, calling CQ, CQ, CQ. Nobody, that's not anything different than, using a barrelfang or a, what do you call it? One of the non-ham walkie-talkies, really, except that you have to use, a call sign that's given to you. We're not going to, you got to get this into this club, you have to do more than just buy a piece of equipment.
Right, to be successful.
Yeah, there are people, by the way, that buy our unit. It's not very many. I think I've run into one, a guy who bought our equipment and expected it to just take it out of the box, plug it in, and you're ready to go. It just works. And it's like, no, it's not quite that easy. I mean, you do have to learn how to tune it. You do have to, So he was very upset with me because it just should be out of the box. Everything should just be out of the box. It didn't have cables with it. He thought they should have cables. They should have labeled for where to plug them into my transceiver. He was plugging things in crazy. I mean, he claimed that he was been ham for many, many years and he understood all this stuff. But he was plugging the key into the audio headphone jack on his. So had the key in, plugged the headphones. And I don't know what he was doing with the other cables. So, of course, it didn't work.
Right. But, I've discovered with almost 800,000 hams in America and almost 3 million hams in the world, that there's a lot of people that have ham radio licenses that have no technical ability. I'm not slamming them for that. That's just the way it is because our great hobby attracts people from many different areas of life. So I guess I understand then, but also it gives you kind of a product roadmap in terms of being able to say, okay, well, maybe we need to include an antenna, for example, as a kit. If it's a prepper kit, it could come with, a whole bunch of stuff as a package.
Right. We actually do offer a go bag. That's actually been a pretty good seller. But what we're about to do, which we have resisted doing for a long time, is to actually break it down into its component parts and offer pieces because, a lot of people already have part of their go bag. And so we've been planning to do this for months. It's just because of all the other stuff going on. Hopefully we'll get the antenna system, which is actually an antenna and a setup kit. Nobody sells a setup kit. We have developed a setup kit that allows you to set the antenna up without any hassles. You have everything you need. You don't have to cut anything. You have to tie any knots. It's all designed to make, and then it's easy to also take down and use it again. I mean, so it's repeatable. So nothing is used up or broken or whatever. So that we have that, we'll be selling the antenna with the kit. We're going to be selling the power system, which is a 2,800 milliamp hour battery bank and a solar panel and the cables. The interesting thing about the power bank, I mean, we found out this early on that you can't trust what they tell you. When you go on Amazon, you can pay anything from $25 to $100 for a 2,800 milliamp hour battery bank. What's the difference in the price? Well, because the one that sells for $25 is actually really only 800 milliamp hour battery bank instead of a 2,800 milliamp battery bank. But the customer doesn't know any difference because they plug it in and it does charge the phone. So we got to the point where we couldn't trust anything, and so we tried to buy batteries and found out that the batteries, you couldn't even trust the batteries. They would put labels on them. They would buy cheap batteries, 500 milliamp hours or less, and then they would wrap a 9,900 milliamp hour battery wrapper on it and sell it to you for $5. And it's only a 495 milliamp hour battery. And we ended up buying battery charging measuring systems and discharging measuring systems so we could determine, whether the batteries really were what they said. So now we just buy them directly from the factory, essentially, through a distributor. And from reputable places like Samsung, LG, or Sony, where we know exactly what we're getting, and that's what we sell. And so while our battery bank will not be as inexpensive as the ones you could get on Amazon, we can guarantee them for the power that they have in them because we put the batteries in ourselves.
Right. Now that makes sense. Eric, I'm so happy that I actually had this opportunity to learn about you and understand where you're coming from. It really answers a lot of questions that I had when you first came to the expo and presented your new Preppcomm transceiver. So I want to thank you so much for coming to the expo, but I also want to thank you so much for joining me on QSO Today. It was a real treat for me, and I appreciate that you came.
Well, I really appreciate what you guys are doing, too. I mean, literally, you guys have helped us launch, and you continue to be a source of revenue for us by us coming to your show and meeting new customers. And, by the way, customers that end up being people that essentially become part of the company, one way or another. We have a couple of guys helping with various engineering tasks right now that are part of that we met at the last QSO Today show. And they said, I want to help. I mean, I want you to be successful. What can I do?
I think one of the great things that I try to stress about the expo, to everyone that comes, is that what we've done on the platform is allow people to create relationships with each other. They have a chance to mingle and meet, and amateur radio is kind of that magnet that kind of draws all these people together. But in the end, what we hope is that people will find their mentor or find their group or find their interest in ham radio, because, as I say, it's a big tent with a midway that has 1,000 tents.
Yep.
So I'm glad that that's worked for you, and I'm glad that you're attracting people to you that are helpful and also are benefiting from knowing you and working with your product.
Yeah, it's been a real great experience, and really, what other show is there out there like yours? I mean, you have a unique product, and frankly, I'm getting to the age where going to a real show, like when we went to CPAC. I mean, it was very difficult, dragging all this stuff around and setting up the booth and taking it down and manning the booth. I mean, I just don't want to do that anymore. Like setting up and running a QSO Today, yeah, I sit there all day talking to people. That's literally what happens. I mean, they come in and we have people that actually, can you believe this? We have people that come in the booth and talk and stay there the whole day because they want to hear what I'm going to say to the next customer.
Isn't it amazing? They learn a lot that way.
That's right.
And you're a very good host, so that also works. Anyway, we're almost at 2 hours, and I think that there's not going to be a lot to cut out of here because I think the conversation was so spectacular. Again, I want to thank you so much. Wish you 73s. I'll see you at the expo, and I'm really looking forward.
Okay. Well, thank you for the interview, and I'm looking forward to seeing some response. That'll be fun.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Eric. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put an AF7YQ in the search box at the top of the page. Be sure to click on the Expo menu item at the top of the page for updates on the upcoming QSO Today Virtual Ham Expo. I am updating it as I have more information. And you should know that on the Expo website now, there is a button for all of the old presentations, which are now on my Vimeo channel and open for everyone to watch. My thanks to ICOM America for its support of the QSO Today podcast. Please show your support of ICOM America by clicking on their banner in the show notes pages. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any other episode into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing the subscribe buttons on the show notes pages. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes pages, or use my Amazon link before shopping at Amazon. Amazon gives me a small commission on your purchases while at the same time protecting your privacy. I'm grateful for any way that you show appreciation and support. It makes a big difference as I head towards episode 400. QSO Today is now available in the iHeart Radio, Spotify, YouTube, and a bunch of other online audio services, including the iTunes Store. Look on the right side of the show notes pages for a listing of these services. You can use the Amazon Echo and say, Alicia, play the QSO Today podcast from TuneIn. My thanks to Ben Bresky, who edits every single show and allows both this host and my guest to sound brilliant. Thanks, Ben. Until next time, this is Eric, 4Z1UG. 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.